Okay, we're back again. Here's my runaway train. So this video follows on from the wayward teenager stealing the steam train and crashing it into the slot, and nobody was hurt. Here you go. So this is train A. That's the runaway steam engine, and it's going that way at 20 meters a second. Here's B, and that's stationary. The train A is 40,000 kilograms. And train B is 100,000 kilograms. There's some writing there about it. It basically says that they collide and the whole thing then carries on. You now have to work out how fast it's going. Equations. Because this is a closed system, the initial momentum equals the final momentum. You can't lose any momentum from the system because all the momentum is contained within it. We would need to state that, and probably in a formula, and write a sentence saying forces are contained within the system, so all the momentum has to stay the same in a system. It is called conservation of momentum. You could even write this down underneath it. Conservation of momentum. Okay, so we can calculate the initial momentum by mv of A. So that will be of A plus the momentum of B. There you go. Nice. This is going to be 0. Why? Because this has a velocity of 0. It's stationary. So the velocity of this equals 0. Which means that this equals 0. That bit was really easy. This mass is 40,000 times 20. 2 times 4 is 8, and you can stick an extra 0 on. So the initial momentum is 800,000. We don't need the units on this because we have not finished answering the question. You've been asked to calculate the velocity of this thing. Now, the final momentum equals 80,000. Because initial equals final. That means we can now do a new formula which would say S equals the mass times velocity. So we can go 80,000 equals the mass of the whole thing, because it's now joined together. So the mass will be 40,000 plus 100,000. 140,000 V. I'll just pause it while I find a calculator for the next part. Alright, so we're back. Now 80,000 divided by 140,000 is 5.7. For those of you who are struggling with the algebra, 80,000 divided by 140,000 equals 5.7. We need to write the answer a bit neater than that, so you can say V equals 5.7 ms minus 1, right. Again, velocity is a vector quantity and needs to have the direction written down. You could argue that I've got the wrong significant figures and I should round this to 6. Why? Because that is only one significant figure, that 40,000. It's not stated that it's two significant figures. That is only one significant figure. That's only one significant figure. So my answer should be one significant figure. So strictly speaking, this should have been rounded to 6. Yes, yes it should. Spot on. Now, the next bit's going to be like some work from your book, like pages from your book. So make sure you've got that and haven't lost it. Thanks. See you later.